Hello everyone, my name is Kamal, and for the Latam Hackathon, I built a stake-backed, decentralized verifier network for Layer 0 that leverages Symbiotic's economic security model to provide crypto-economically secure cross-chain messaging verification system. So we all know how much cross-chain messaging is critical for the blockchain interoperability, but current verification systems lack the economic incentives. Like what if some malicious validators verify false messages? How do we actually ensure that the validators have some skin in the game? Presenting the symbiotic powered layer 0 Debian, this Debian implementation bridges layer 0's messaging protocol with Symbiotic's restaking infrastructure, essentially creating a verification layer which is backed by real economic stake. So validators stake assets through symbiotic vaults, and their voting power determines the message verification outcomes. We have got several key features like stake-backed security, BLS advanced signatures, and slashing mechanisms, including a layer 0 integrations, of course. We have a layer 0 Debian interface. And this is the whole architecture for our project. At the highest level, we have three main components, including the first is the layer 0 protocol layer, which handles the cross-chain messaging. Then we have a Debian implementation, which is the verification layer that we built. And then we have a symbiotic infrastructure, which provides the economic security through staking. On a high level, this is how it works. So in the layer 0, we have a source chain and we have a destination. So the source chain sends the message to a layer 0 endpoint, and the layer 0 endpoint assigns the job. And then we have a symbiotic Debian contract, which is our implementation. It submits the verification to the Debian worker service and requests the signature. And the Debian working service aggregates the BLS signatures and gets it to the symbiotic relay network, which derives the voting power from the symbiotic vaults. So we can straight jump to the code and run it. So this is the main Debian contract, the symbiotic Debian. You will find it inside the contracts folder. And this is where we have key functions implemented. So this implements layer 0 Debian, which is an interface for the layer 0 Debian, which is like the decentralized verifier network to be built on the layer 0. And then we have symbiotic integrations and symbiotic interfaces as well, like the operator registry and everything. So here, the key functions that we have in this is like assign job. So this function is called by layer 0 when a message needs verification. It emits a job assigned event, and the Debian workers listen for this. Then we have a get fee function, which basically calculates the verification cost. The base fee is 0.0025 ETH and scales with confirmations and message size. And then we have a submit verification function, which basically workers submit aggregated BLS signatures, and this verifies through settlement contract, checks quorum threshold meet, and notifies layer 0 of verification. Then we have a voting power provider. So the voting power provider contract basically ensures voting power is equal to the actual economic stake. Now let's check the status of the contract on Sepolia. So we have actually deployed the contracts on both Holsky and Sepolia for cross-chain messaging, and here you can see that register as operator is true. This checks in all real-time, Debian deployed is true, and this is the different addresses present and the network. Similarly, we can check for Holsky also, and we'll see that it has been deployed on Holsky, and the cross-chain messaging feature works from Sepolia to Holsky. So as you just saw this, and then we can register the validators on Sepolia, for example, by running this command. So here it will first ask us to check the to select the vault for staking. We can select the vault, and then we have opted into the vault, and then we can enter our BLS key or press enter to generate, and it generates a BLS key, and then it basically opts into the Debian network, and it registers as a symbiotic operator. And similarly, we can do for Holsky, and then the cross-chain messaging feature works with the symbiotic Debian that we have built.